I'm waiting.
Oh. Okay, now a tricky question. Okay, so let's say when it's written like that, then that means a reduction from 3 plus to 2 plus. So this is consistent with your table value. So if this is written as E naught, then the E naught 3 plus to 2 plus, represented by comma, then the plus quantity. So similarly, from this one to this one is reduction, right? Reduction. From the table is a minus quantity. Okay, so a tricky question is the direct mixing, whether it will give you a chemical reaction or not. So let's say this is Fe, obviously, is 2 plus, right? Simply pour in the lithium metal. Then you are asked, is it going to react or not, right? So with knowledge, then you can have an answer. Now, if the Fe2 plus reacts, right, then it has to change into different chemical. So let's say it is going to change into Fe3 plus. So this is just an example. Okay, so this is oxidation from the information provided. So you are asked to make the prediction based on the information provided. Okay? So in case anything happens, then you're going to form a 3 plus. So this oxidation, then that means your potential is going to be minus 0.771 instead of plus 0.771. You switch the other way around. Okay. So for lithium, based on the information provided, if reaction happens, then lithium will become lithium plus. Yes, whose hand was the lady first?
Yeah.
You do it first. Okay, but I thought you said we only change the sign when it's negative value.
When you switch, then the sign is going to be opposite. See, there's a reduction potential. As you switch into oxidation, then the potential is going to be minus, opposite to each other. Switch, meaning put a minus in front.
So in this case, you do it for both, though, right?
Right.
Because the lithium going to the oxidized state.
Because then that what you had written up at the top is actually reduction for.
That's right. That's what I was explaining to the class, that is written this one first and this one next, then obviously it is reduction from left to right.
Yeah. How do we know that the iron doesn't get reduced? Why can't the iron be reduced?
Because
Okay, with the information provided, that's the tricky part. You cannot do any other thing. Your prediction is going to be based on this here.
Okay.
So it's redox. So either this one is reduced or this one is oxidized. So based on the information available, test your knowledge rather than seeing the whole picture. Yes.
So lithium is a strong oxidizing agent?
Well, not yet.
Yeah, it is.
Not yet. Looking at this here. Now, so in case the 2 plus reacts to form that based on the information, then it must be 3 plus. We don't care whether it's Fe neutral in this case. Okay, for lithium, on the other hand, in case anything happens, it's going to be oxidized. So lithium is going to be oxidized. Like that, then will be like this. Okay, so the buck stops here. You cannot have 2 oxidation reaction. Cannot. So you say, okay, something happens, then it's going to be like this. If anything happens, it's going to be like this. But you cannot have 2 oxidation number. I mean, you cannot oxidation half reaction. Therefore, no half reaction, no complete reaction. Yes?
And it has to happen this way.
Well, that's correct. You are stuck with the information in hand. You don't have any more information.
And
Other
the reason,
information.
okay, one more question, and the reason,
You just cannot have two oscillation
Well,
But
reactions.
why
That's
can't
right,
we
that's
flip
what you
the
said.
first one back to a reduction? Why can't we go?
Why can't you go from 2 plus to 1?
why did you change it
Why-
like
yeah,
that,
why
why
can't-
doesn't work?
Here, you are provided with this chemical, the Fe
Oh,
2
we're-
plus.
okay.
Now, therefore, if you want it to work, the observation, use Fe3 plus.
And so we're given that then.
We're given
that.
iron 2, okay.
Yeah.
Or we're given that. We begin
Yeah,
with
you are
iron.
given this, so this is, this is knowledge.
We'll be given both though, right?
But
No,
I know,
no.
right?
So you're going to be provided with this chemical and this chemical, and based on the information in hand.
Well, I think
Okay.
we're just confused on how you would know that it's going to 3 plus and not 1 plus without having the product.
Well, again, I emphasize, you must use the information in hand here.
So you would give us that value from
That's
the
right,
value
I
to-
give you that.
We would know that we can only go between 2
Yeah,
plus.
I said
Okay.
given.
Okay,
So
so that's
I
the
will
key there.
be stubborn on
Okay.
that to test your knowledge based on that, just like you don't have any other tables available.
So if we were given just hypothetically, if it was Fe 2 plus 1 plus, then we wouldn't know that we could do it.
That's correct.
Okay.
That's correct. Yeah. Because without any other information, you do not know anyway, right? You don't know the relative potentials, right? You don't have that fantastic memory.
I have a hunch.
Huh?
I have a hunch.
A what?
A hunch.
What is a hunch?
You know, like an idea. I have an idea.
Oh,
that it's gonna-
okay. Well, your idea is going to be based on the potential. You know, you cannot claim gas that, I have Fe neutral, I can Fe 1 plus, then that can be really far out to gas. That is not knowledgeable gas then. Okay, so electro potential, right? So the E naught, meaning standard condition, 1 molar concentration. Then what about translating into E of any concentration? So that is experimental quantity. How do they relate each other? So this is your half reaction. The relationship can go to the half reaction. So now this is your Nernst equation, as you remember. Not the Nernst equation, but Nernst. Okay, notice it is a plus. When it's a plus, then the ratio here is oxidized over reduced. Okay, now if you like to use minus, then for convenience, then this would be flipped. What I mean by convenience then is product over reactant, right? So when you're looking at this two, then this is product over reactant. But keeping in mind, you need to use minus then. They are the same thing. The same Nernst equation. Okay, so all these are units and constants. Okay, so Faraday, so you can kick in the Faraday, then you can kick in the gas constant, then you can kick in room temperature, then it will be a numerical value, that is 0.059. Yes?
Okay, just to clarify, so if that E is positive, then we keep the ratio, but if that E is a negative voltage, then we flip it? Is that what
No, this is algebra. This is just algebra, right?
Oh, okay.
So this is a Nernst equation with a plus, then is this ratio. So if you say that I like to use product over reactant, then you can incorporate a minus instead. Okay? Any question? Okay. Okay, the meaning of that, right? So E represents the experimental quantity. So let's say this is your electrode. So you put a conductor, then this is your couple, oxidize, reduce, forms. So when you write the half reaction, this is what it is, half reaction. Then when you look up the table, then this is the sign and magnitude, sign and magnitude. So this refers to the two concentrations are 1 molar. This is 1 molar. So this relates to the experimental quantity. Then what will be the experimental quantity? Then is if you calculate, then it will be written like this. Okay? So it is going to be, I put in the 0.1, so oxidize over reduce. Then you can calculate that to be this quantity. Okay? Now notice something interesting. Now this is when everything is 1 molar. 1 molar, you get 0.15. Here, you 10 times less than 1. This is 100 times less than 1. Yet, your potential is higher than that. Okay, so is it interesting? This is the ratio that gives you the initial potential. So in terms of battery, then this one is your initial voltage, but this could last a lot shorter than what that can last because of capacity. Okay? Any question?